right, so this is one of those ones where it doesn't seem like it gives you very much information. Okay, so we have a bolt that falls off a roof. Something just falls off. How fast is it going initially? 0. It's like being dropped. Okay, so we know our initial velocity is 0 meters per second. And it says it falls 6 meters, so that'll be our displacement. Okay, what rate does it fall at? 9.81 meters per second squared. So that's the other thing. It doesn't outright tell us, but we kind of have to get from the context of the question, right? So we're looking for how long it will fall. So we're looking for the time. Okay. So the formula I'm going to need to use is this one. You know, that one I told you you'd never have to use to find time, unless VI is 0, which it is. Okay. Since VI is 0, I can just get rid of this whole thing and say d is 1/2 AT squared. Right? I'm going to isolate t by going d over half of a square rooted. Okay, that'll give me t. So I'll have 6 divided by 1/2 times 9.81. Now, because the 6 and the 9.81 are both down, I'm not making them negative. Okay, so if you're looking at that and going, that's down, that should be negative. It could be, but then they'd both be negative. Right? I'm just going to say I don't have to worry about that because it doesn't change direction at any point. Okay. So when I plug those in, okay, so we're going to have square root of 6 divided by 4.905. That's half of 9.81. Okay, so we're looking at it's going to fall for 1.1 seconds. Okay. Everybody all right with that one? Okay. Try that one. Okay. I think I've got one here for every formula that we went over last week, just to review them all. Okay. So on this one, we're looking for the final velocity. Okay, so we're looking for VF of a rock that's propelled over a displacement of 0.30 meters. Okay, by an acceleration of 22 meters per second squared. Okay, for 0.72 seconds. All right, so I'm looking for a VF. I have D, A, and T, right? I would say my best bet for a formula here is D equals VF times T minus 1/2 AT squared. Right? And I'm looking for VF on this one. All right, so I'm going to add the 1/2 AT squared over to the other side. Okay, and then I'm going to divide by T, and that will leave me with VF. Okay, I'm going to plug in my numbers. So 0.3 meters times, plus 1/2 times 22 times 0.72 squared divided by 0.72. Okay, remember those 0.72s don't cancel each other. Okay, so we can't do that mathematically. So we got 0.3 plus 0.5 times 22 times 0.72 squared divided by 0.72. All right, so we're looking at a final velocity of 8.3 meters per second, and that would be positive. We weren't given anything else, okay, for direction. So positive 8.3 meters per second. Okay, questions on that one? All right, so a reminder from last week, we decided that kind of the big thing with acceleration questions was getting our givens written down so that we could decide what formula fit best. Okay, and go from there. And that's the important skill we have to have, is going into projectile motion, we have to be able to calculate or use acceleration formulas to calculate bits and pieces about the projectile motion. Right? And to do that, we have to be able to do this. Okay, try this one. This one you're looking for initial velocity. So we are looking in this one, okay, for the initial velocity. So we're looking for VI, okay, of a bullet that enters ballistics gel and slows at 150 meters per second squared. So that's our acceleration, and it's going to have to be negative, okay, because it's slowing, right? It does that for 2.2 seconds, okay, and its final velocity is 65.2 meters per second, and that would obviously be in a forward direction. The bullet can't go backwards after hitting the ballistics gel.
Does that say 0.252 seconds?
Sorry, yes, it says 0.252 seconds. Sorry, I wrote it. I said that and then I wrote it differently, didn't I? 0.252 seconds. Okay, so this is the givens we've got, okay? And I would say that to do this one, we will use our change in velocity over change in time formula, right? Looking for VI. So what I would do is multiply both sides by t, then I would add VI to both sides so that I'm not solving for a negative number. Then I'm going to subtract t times a back over. Okay, so VI will equal my final velocity minus the change in velocity, that's t times a. Okay, so when I plug my numbers in, that's going to be 65.2 minus 0.252 times negative 150. Okay, and that negative has to be in there, otherwise you're not going to come up with the right answer on this. Okay, so we'll have 65.2 minus 0.252 times negative 150. Yeah. All right, so it entered the ballistics gel at only 103 meters per second, which is not very fast for a bullet. Okay, but that's the speed we got. So, okay. Questions on that one? Try this one. This one you're looking for how far a plane flies while accelerating at 4.52 meters per second squared, starting from a velocity of 123, going to a velocity of 300. Okay, so you're looking for D. Okay, so let's have a look at this one here. So we're looking for how far the plane flies, so we're looking for a distance. Okay, that's our question mark. It's accelerating, okay, positively, 4.52 meters per second squared, from 123 to 130. All right, so this is the formula that we went over on Friday. Okay, it's our last acceleration formula, and it's this one. VF squared equals VI squared plus 2 times A times D. Okay, you're never given the time in this one. All right, so we're trying to solve for D, so the first thing I should do is subtract VI squared from both sides. Okay, that's going to equal 2 times A times D, and then I'm just going to divide both sides by 2A. That'll leave D by itself, and then I just plug in my numbers. So 300 squared minus 123 squared divided by 2 times 4.52. Okay. Now, what do you suppose the most common mistake people make when they're using this formula is?
Maybe not putting brackets around like the top and the bottom, like doing this separately.
That's one of them, yeah, is just typing this straight into the calculator, and then of course your calculator does order of operations, which is not what you want. Okay, the other most common mistake?
Subtracting them and squaring them?
Right. Messing up the squares, either forgetting to square entirely or subtracting these numbers, because I made that mistake on Friday, right? I wasn't thinking. Okay, so you subtract these two numbers and then square the answer. That's not the same as squaring those two numbers and subtracting the squares. Okay, so those are the mistakes I usually see. They usually involve the squares, okay, on questions that involve this formula. All right, so we should get 8.28 times 10 to the 3 meters, okay, when we plug that in to our calculator. All right, so it's not a very large rate of acceleration. Okay, it's a pretty small rate of acceleration, and we're talking about a pretty large change in velocity. So it's going to take it quite a distance for that to occur. All right, questions on that one? Okay. Then try this one. You're looking for the initial velocity of a runner who finishes a race at a velocity of 15 meters per second. The race was 150 meters long and took 21.2 seconds. I will add to that he accelerated uniformly the entire time. Okay, so on this one here, we're looking for VI. They're asking us for the initial velocity. Okay, they finished the race at a velocity of 15 meters per second, so that's our VF. Okay, the race is 150 meters long. Okay, and it takes them 21.2 seconds. All right, so that's what we're looking at there. Okay, so looking for VI. The only formula I have that can do this is this one, the one that uses average velocity, provided there's uniform acceleration, okay, times t. All right, so if I want to get VI by itself, the first thing I need to do is divide both sides by t. That'll get rid of my brackets. Then I'm going to multiply both sides by 2, and then I'm going to subtract VF. Okay, so I'm going to have 2 times D over T minus VF will leave me with VI. Okay, so that'll be 2 times 150 meters divided by the time, which was 21.2 seconds, and then subtract our 15 meters per second. Okay, so 300 divided by 21.2, and then subtract 15. All right. Is that okay? Is it okay that I get a negative number? Just means they were what? Yeah, they were moving backwards. Okay? That actually happens a little bit. If you're in starting blocks and the gun goes, sometimes people rock backwards slightly just before they push off. Okay? And so they could have had a slightly negative initial velocity there. All right. How are we feeling about the acceleration stuff? You guys feeling okay about that? Like, basically, it's just a matter of you have to find which formula fits with what you have. All right? And it's always going to be that way, including when we get to the projectile motion problems. All right. So on Friday, we worked kind of off of that worksheet, okay? And were there any problems from the worksheet? Anything we needed to go over that was giving us trouble? Everybody was okay with that? Okay. I'm going to give you guys about a 5-minute break here or so, and I'm going to start projectile motion. And if there's no other questions on acceleration, then I'm going to start that. Tomorrow's quiz will, of course, be on acceleration, so it'll get kind of an idea how well we're really looking at that. Okay, so 5 minutes. Okay, go get a drink in the bathroom, whatever, back here.